With trig identities, we always want to start with the more complicated side because that's the side where there's more to do. On this one, the left side is more complicated, I would say, because we have to the fourth power. So that is a difference of squares, and that will factor to sine squared plus cosine squared times sine squared minus cosine squared. And I'm not touching the other side of the equal sign. That's awesome. We should recognize that sine squared plus cosine squared is 1. And we're going to write out that step. Since this is a proof, we need to make sure we write out every step. We shouldn't need any explanations because our steps should follow so clearly. All right, now we need to think about matching the other side of our equation. So the other side of our equation is 2 sine squared minus 1. So I don't have any cosine squares on the other side, it's just sine squareds. So what I need to do is change cosine squared and put it in terms of sine. So my sine squared here in front is going to stay the same. And cosine squared is the same as 1 minus sine squared. I'm going to drop that in parentheses. Always, always, when you're doing that substitution, drop that in parentheses because that negative applies to all of cosine squared, and it also applies to all of 1 minus sine squared. So now we need to distribute in that negative. So I have sine squared minus 1 plus sine squared. And then we have like terms we can combine. Sine squared plus sine squared is 2 sine squared minus 1. And it's equal to the other side. Done. Again, we started with the left side of the equation. We just did legal algebra in order to make it match the right side of the equation.